let's take a look at the sketches of sine and cosine functions with periods other than 2 pi. First of all, for a number b greater than 0, the graph of y equals sine bx, or cosine bx, will have a period of 2 pi over b. Remember what period means. That's the length of time that it takes for the graph to start repeating itself again. We saw that the sine function had a period of 2 pi. The cosine function also has a period of 2 pi. I think we also looked at the tangent function. Tangent had a period of pi. For example, let's find the period of y equals sine of 2x. Now notice in this case our b is equal to 2. So let's figure out the length of time that it's going to take this function to start repeating itself. Well, it says that if we have sine of bx, the period is going to be 2 pi over b. So the period is 2 pi over b, which is pi. So that's going to be the length of time that it's going to take for this graph to start repeating itself again. We'll sketch it here in a second. To graph these things, to graph y equals sine bx, or y equals cosine bx, the graph will look exactly like sine or cosine, except the period will be different. That is, the graph will repeat itself at increments of 2 pi over b. So let's see if we can sketch the graph of y equals sine 2x. So what I think I'll do is I'll create 2 little grids here. So maybe there's pi halves, pi, 3 pi halves, 2 pi. I'll do the same thing down here. Pi halves, pi, 3 pi halves, 2 pi. Now let's go ahead and graph sine x up here first. Remember, sine starts at 0, 0. It looks something like this. Okay? And we can do the other side. Okay, so there's a graph of sine x. Now, we want to graph the graph y equals sine 2x. Now remember, sine x had a period of 2 pi. It took an interval of 2 pi to start repeating itself again. Every 2 pi, the graph's going to repeat. Well, the graph of y equals sine 2x has a period of pi. So the graph is going to look just like sine x, except the humps are going to be closer together. So if there's 1, there's negative 1. It's got to make a complete pass on an interval of pi. So it's going to look something like this. Let's see. It's going to start here, peak. Okay? So it's kind of squished a little closer. So it made one pass here. Now it's going to make another one. And did it again, repeated in an interval of pi. It'll do it again, etc. And we can certainly graph it over here as well. It's going to look something like this. Notice every interval of pi, the graph repeats itself. That's what period means. If we wanted to graph sine of 3x, it would just be quicker than that. Okay? So that's all there is to graphing periods. Eventually we're going to put numbers out in front. We'll do period and amplitude at the same time. Plus we'll shift these around a little bit. Okay? So do your homework problems. There will be lots of problems for you to sketch these things. Just remember to find the period of y equals sine of bx or cosine bx. the period is just 2 pi over b.